Hello everyone, I am Gianmarco Roggiolani.
And I'm Matteo Sodano.
And today we will present you our work, Hierarchical Approach for Joint Semantic, Plant Instance and Leaf Instance Segmentation in the Agricultural Domain. Plant phenotyping is a central task in agriculture as it describes plants' growth stage, development, and other relevant quantities. Phenotyping is the result of the interaction between the genotype of the plant, human management of the fields, and the field environment. Robots can help automate phenotyping by estimating plant traits, such as the number of leaves, leaf area, and the plant size. In this paper, we address the problem of joint semantic, plant instance, and leaf instance segmentation of crop fields from RGB data, so these are the three tasks that we will refer to. Combination of semantic and distance segmentation is called Panoptic segmentation. In the literature, this task is usually addressed with a shared encoder that extracts meaningful features from an image, and separate decoders addressing the different tasks. So each task is executed in parallel without exploiting potential relationship between them. This is suboptimal for phenotyping because it treats each task separately, without considering that plant instance segmentation can benefit from the knowledge of semantic segmentation between crops and soil, and so can leaf instance segmentation from plant instance segmentation. Our approach consists of a convolutional neural network predicting centers and offsets for the plant and leaf instance tasks. The main novelties we introduce are a hierarchical skip connection scheme and a new automatic post-processing operation. For the skip connections, instead of following the usual encoder-decoder scheme, we exploit the feature extracted from the decoder of the previous task to augment the features extracted from the encoder, from semantic segmentation to plant instance segmentation, and from plant instance segmentation to leaf instance segmentation. Here there is an example of our post-processing for the leaf instance segmentation given an RGB image. The network predicts centers and offsets. So, in the second image, which is the top center one, we see the centers that we keep after thresholding and non-maximal suppression operation. In the top right image, we see the predicted distance for each pixel from its center, computed as the Euclidean norm of the offsets. In the bottom left image, we see in green the pixels whose distance from a single center is below a defined threshold. In yellow, all pixels that could be assigned to 0 or more than one center. We can already assign the green pixel to an instance ID, whose result is shown in the center bottom image. All the other pixels are assigned via voting mechanism to produce the final instance mask, which is the bottom right image.
We evaluate our approach on two different datasets, one of sugar beets and one of cauliflowers. In the plots, we have the intersection over union, the metric for semantic segmentation on the x-axis, and the panoptic quality, which is the metric for panoptic segmentation on the y-axis. This means we want to be in the top right corner of the plot, indicating high results for all the tasks. Most of the approaches needs to be trained twice, once on plant instances indicated with P and once on leaf instances indicated with L, which results in different IOU but also in inconsistent masks. These approaches are indicated with the dashed line. The solid line indicates approaches that perform plant and leaf instance segmentation together. The sugar beets dataset, our approach outperforms all baselines in terms of both metrics. On the cauliflower datasets, we have slightly lower IOU with respect to Panoptic DeepLab, but we have the highest Panoptic quality for both Panoptic tasks. As mentioned, our skip connection scheme fuses features from the encoder with the features of the previous task's decoder. We evaluate our skip connection scheme in orange, comparing against the case of no skip connections at all, which is in blue, the usual encoder-decoder strategy in red, the skip connection coming only from the previous decoder in yellow, and the same strategy as the one we proposed, but disabling the gradient flow for the skip connections in green. We can see from the plot our scheme achieved best results on all metrics. Last result we propose is the comparison between our novel post-processing operation and the one proposed by Panoptic DeepLab, which also relies on predicted centers and offsets. As we can see, changing only the post-processing does not impact the IOU since semantic segmentation is independent from it, but our post-processing has better results on the Panoptic tasks, especially for fine-grained tasks as the leaf instance segmentation. To conclude, we propose an approach for joint semantic and instance segmentation on plant images. We introduce a novel skip connection scheme that exploits task hierarchy and an effective post-processing operations for instance segmentation. Also, our model allows real-time inference at 25 frames per second. Don't hesitate to contact us for any question, and our code is publicly available on our website. Thank you for the attention.